Welcome back, friends. We have been building the Caesar cipher. In this video, we shall see how we can use the same function that we created to also decode a Caesar cipher. Now, what that means is that if I have a plain text message, I create that into a secret message, a cipher text by using Caesar shift. By doing one more round of Caesar shifting, Caesar cipher, I can in fact get back my original text. Now to see this clearly, I'm going to show you the diagram that we used earlier where I have these letters on a disk and I have also got numbers which correspond to the indices of these letters in the string called letters, right? So A is 0, F is 5, N is 13 and so on. Finally, Z is 25. Now remember we spoke about the modulo operator, and basically we realized that anytime I want to give a positive shift, I just have to move in the clockwise direction along this disk. Now just look at this diagram carefully and you will realize that if I were to start from any point and make a round of 26, in fact I'm going to come back at exactly the same point. Say for example I started at 8 and I took 26 steps, I'm going to end back again at A. If I started from T, I did 26 steps, I'm going to come back again at T. What this means is that if I were to decode something, let's say something has been shifted by 5, in which case all the letters have been shifted by 5. If I do a further shift of 21, which is 26 minus 5, I am going to get back my original string. In fact, we can see this mathematically. If the new index, let's say, if we have index plus n, modulo 26, and I were to put this as 26, you will see that once again we'll be back at index after this function. So what the point here is that we can use the same exact function that we have created earlier, except that I have to give a shift which is 26 minus the shift that had been used for encoding. Let's just see some examples of this. For example, let's say we had a message called ABC and a shift of 1. So we'll get a secret message BCD because each letter has been shifted by 1. To decode this, I can just shift it once again. I can take this message and give it a shift of 25 because 26 minus 1 is 25. Similarly, shift of 10, I get KLN. I can get this by shifting a further 16, which is 26 minus 10 of 16. ABC 25, I can get this, say I get ZAB. To get this ABC back, all I have to do is to really shift by just 1. So Z is going to become A is going to become B. But interesting point is 26 minus 25 is 1. So what we are saying is that the same function as encoding will be used, but the shift value should be 26 minus the shift used for encoding. I hope this is clear. Let's just see this in the code. So one thing we have to realize is that this 26 business is for letters, because if you're dealing with numbers, then the new shift should be 10 minus numbers because we're dealing with 10 numbers. However, let's just do this for letters first. So let's say I have a string Python is cool and I encode this. So I run my code, all the letters, small letters. We have made this modification last time. So if I were to look at, let's say x enc, it is, let's say, some ud whatever, for Python is cool because I've given a shift of 5. Say I did once again, so I call it, say, x decode is given by x, so say again Caesar, say cipher, and I give, say, x enc, and this time I give 21 because remember we had used a shift of 5, so I'm going to use a further shift of 21. If I were to do this and I look at, say, xdc, it is indeed Python is cool. So in fact we can just bring this x, say dc equals to Caesar, say cipher, let's say x enc and 21, then we will get the message back, right? So I'm just going to clean this function a little bit and then we'll take a few examples and basically just going to remove these prints, right? Since we have already understood how this works, I'm just going to comment this out because they seem to be taking up too much of the screen, right? So now if I run this, indeed x enc is whatever it is, x dc, x dc is Python is cool, right? We can try this now, right? So let's say instead of Python is cool, let's say let it Python cool, I say shift of 12. Over here I must give a shift of 14 and this will bring me back to to the string Python is cool. So if I say x is Python is cool, x enc is something else, p whatever, x, but if I look at x dc, I am back with Python is cool. Now really, like I said, this is for letters because there are 26 letters. We can actually try with numbers also. Remember, our function is capable of handling numbers. If I were to try, let's say, Caesar shift of say 1, 2, 3, 4, 5, and I give a shift of say 3. Now, to undo this shift, I'm going to have to give a shift of 7, because this time round I need a shift of 10 total to get back to my original, right? So let's just try this. If I gave a shift of, let's say, so x is 1, 2, 3, 4, 5, x, e, and c is 4, 5, 6, 7, 8, because 1 has become 4, 2 has become 5, and so on and so forth. And x, d, e, c is again 1, 2, 3, 4, 5, because remember 7 plus 3 is 10. Now, one thing I want to highlight is that though this is looking like numbers, but really these are strings, because notice there are these apostrophes around this. Right? So do not mistake this to be a number. These data types are important. We are really, really, really dealing only with strings over here when it comes to this encoding and decoding. I hope this is clear enough. Any questions, I'll be happy to answer. Take care, enjoy this process, and enjoy programming. Thank you so much.